Okay, so this video is going to be a lightning fast proof of the formula for a geometric series and to talk really about what a geometric series is. If you are stuck on a particular line, you may want to hit pause and look it over and then go back and play back the last few seconds to see it again, because I am going to have to go quite quickly. So a geometric series, the sum of the terms in a geometric sequence. So remember, the first term in a geometric sequence is u1. The second term is u1 times r. And the third term is u1 times r twice. And this just continues on. And that general term, the last term, is u1 times r to the power n minus 1. So if we added up all of these terms, I'll put my addition signs, this would give us the sum of the n terms in a geometric series. So the question is, how do we add all these up without actually calculating all of them and adding them up? That's a really good question. Well, we kind of play a little bit of a trick. I don't want to add all of these things because there's a lot of terms. Like right before here, there's a ur to the n minus 2. And then all the way in between here, there's like a bunch of terms. There's like n of these total terms. So I'm going to do something that comes from grade 10 linear systems. I know this isn't a linear system, but it is a polynomial, so I think it's fair for me to do it. I'm going to multiply everything by r. So I'll multiply the left side. So this is r times Sn. Remember, r is that common ratio. So this would be u1r. This term will be u1r times r, which will be u1r to the power 2. Basically, this exponent is just going to go up. So this is u1r to the power 3. And this exponent's going to go up 2. So this is u1r to the power n minus 1 because it increases, because 2 turns to 3, n minus 2 turns to n minus 1. And my last term turns to u1r to the n because n minus 1 increases to n. Cool. So I multiplied every single term in this by r. Great. Well, now what am I going to do? I'm going to call this equation 1. I'm going to call this equation 2. And I'm going to take equation 2 and I'm going to subtract equation 1. Now, in doing so, on the left side, I have r(Sn) minus Sn, because I have this term minus this term. But something really cool happens on the right-hand side. Not so much for this first term and not so much for this last term, because remember, I'm subtracting up, right? I'm taking 2 minus 1. So I'll start with this one, u1rn. Are there any terms in the top one that look like u1rn? Well, no. So this is going to be u1r to the power n. But then u1r to the power n minus 1, I'm subtracting a u1r n to the power, r to the power n minus 1. So that'll cancel. And then, hey, wait, over here, those cancel. And those cancel. And now I think we can imagine that that term is represented somewhere in here. And I think that we can imagine that this term is represented somewhere down here. And so all of these terms cancel. So really all that I'm left with is u1rn minus ur. Cool. That makes it look a lot easier. But the problem is I don't want 2 SNs, I want 1 SN. Factoring is a religion. I'm waiting for you to shout it out right now. We common factor first. So I'll factor out Sn, leaving me with r minus 1. While I'm at it, I'm going to factor, this shouldn't say ur, it should say u1, because this is just this term. That's a 1. So I'm going to also factor out u1. That'll leave me with rn minus 1. And now I have just one step left. Sn equals u1 rn minus 1 over r minus 1. But of course, as we just saw in our examination of rational functions, r can't be equal to 1. And the reason why r can't be equal to 1 is because Well, if r is equal to 1, this whole thing is kind of pointless. And actually, that's not true. R can be equal to 1. It's just you're not going to be adding up a very interesting. Or you could be adding up 2 plus 2 plus 2 plus 2. Or just any number, e plus e plus e plus e. It just really doesn't matter, because then it would just be, well, you just multiply the first term by the number of terms. So there's really no point in worrying too much about r equals to 1. This formula can be manipulated, and it's something that you will see in your data booklet, and that is the sum of a geometric series. So let's consider an example just to finish this video off. So let's add up the 10 terms of this particular series. So let's go example. Find S10 given, let's go U1 equals 7, U2 equals 14, U3 equals, anybody know it? 28. And that's our geometric series. So just a key point with geometric series is to determine your value of your common ratio, you take the term and divide it by the term before. So we need to find the number to multiply to get to here. So that's going to be 14 divided by 7. So our value of r in our solution, we know that U1 is equal to 7. We know that r is equal to 2. We know that n is equal to 10. And so all we're going to have to do is substitute. So S10 is equal to 7 times 2 to the power 10 minus 1 all over 2 minus 1. Well, 2 minus 1 is easy. So it becomes 7 times 2 to the power 10 minus 1. Now 2 to the power 10, 6, 7, 8, 9, 10. Is it 1024? Yeah. So 7 times 10, 23. So this is going to work out to be 7,161. Yeah. And that would be the sum of the first 10 terms of this entire thing. So you can see that the next few terms are going to get quite large quite quickly. And that is proof of the formula for the sum of a geometric series and using it in a particular example.